Alright, hello students. So, we're looking at a tracing problem here. Tracing is in reading code to determine what it will do. Now in this case, we're kind of going in the opposite way as we do usually, in which we're given an output. In this case, this shrinking, this triangle of numbers, and we are determining what code segment could possibly produce it. So in order to do that, we notice that we're going to be working with some kind of for loop. Generally, when we have rows and columns, then we're dealing with nested for loops, just like our asterisks lab, which I remember you all very much enjoyed. Alright, so we're looking for something that's going to use the same number for each row, but increase as we go down the columns. That's the kind of thing I want you to notice. What changes in the row, and what changes column by column. We'd have a very different problem if it was all ones along the side, and then each of the columns had, a different amount. It'd be a very different issue. So to go through this, I would actually just go ahead and start with the very first one and say, okay, given this problem, what would it do? Well, since j is going 1 to 5, k is going 1 to 5, and I'm printing out j each time, that means when j is 1 and k is 1, I print out a 1. When j is 1 and k is 2, notice I'm going right into this, j is still 1, but k goes up by 1 to become 2, I still print out a 1. So far I have 1, 1, so that's lining up so far. I go up to 3, and another 1, and then 4, and another 1, and then I go up to 5, and remember 5 is going to be our last value that we do. That's another 1. Okay, well that's pretty good. 5 ones, just like we have over here. Now, when we go on to j equals 2, this is where we get a slightly different thing. K starts at 1. I print out 2 for that. Good so far, because the next row is supposed to be 4 2s. So if we keep going at k values, each time printing out 2, we notice our issue, hopefully. The issue is that k is still the inner for loop still gets incremented 5 times, meaning that we have 5 2s instead of just 4 2s. So with it printing out now 5 2s, because k still made this loop print out 5 times, that already invalidates it, since we know that we need to have 4, not 5. So I'm going to go ahead and erase this section of code and start on the next one. Okay, this one's going j equals 1 less than 5, so still the same thing, and k equals 1 up until j. So let's start off at 1 1, which is valid. 1 is less than 1. We print out j, which is 1, so that means we found a 1. Alright, now we try to go up to 2, and we notice we are now no longer less than or equal to j, so we can't do 1 at 2. We have to go on in the outer for loop to j equals 2, k equals 1, and at that time we're going to print out a 2. Already you see an issue. I print out one single 1, but I'm going to print out some number of 2s, and that's obviously going to be wrong, since there are supposed to be 5 1s, not a single 1, but 5. So B is also out. Let's keep going. There's C. Alright, J is going from 1 to 5. K goes from 5 down to 1. Now, I'm actually going to stop right there. Take a look at that. How different is C from A? It's the same numbers it's going through. Same sign, less than or equal to. It's the same thing. Let's just go ahead and call this wrong immediately. That's going to give us 5 every time. So we're left with now 2 of them. And these 2 are looking a lot better. Let's go ahead and start writing them through. Okay, j equals 1 through 5 as normal. Starting at 1. K is 5 down to 1. So we start at 5 here. Now print out j, so we're still okay in that end. Still print out a 1. We go down with k, down to 4. 4 is still greater than j, which is 1. So print that out. And if we keep going, we notice that we keep printing out 1s. since it's still less than or equal to. And we have 5 ones now. To try to go down to 0, we know that 0 is not greater than or equal to 1. So we know that's where we stop, right there. 5 ones, just like we're supposed to have. So far, D is going okay. Now let's try for J equals 2. K is 5. We know we print out a 2. 5 goes down to 4. It's going to be another 2. Goes down to 3 for another 2. Goes down to 2, and we know that's the last value it's going to show. So that's going to be a 2 right there. We go on to the next one. I think that we can go ahead and see our pattern. That it's going to keep going down in numbers. So this is looking pretty good right now. The way we know that this one is not correct is because we are printing out K each time, which actually might be okay. Let's see the difference there. I think we're all aware that this one seems to work. Now at this point, if you do find one that works and all that, go ahead and just assume that's the right answer, unless you really do want to check it with another one because you have time. Generally, you don't have time, so anyways. So J equals 1 to 5, and K equals 1 to 5. So we start off, and we have J equals 1 and K equals 1. Alright, and in that case, we print out K, which is equal to 1. So we're good. Now that might trick some of you. Keep going, K is now 2, right? Because we incremented it. That's a 2. 2 is less than 5, so yeah, we do something. We print out K, not J, we print out K. Meaning we print out a 1 and then a 2. Now we print out 3, 4, 5. Now, that's clearly not what that is. So this one's not okay. So the way we know immediately it's not okay is because it's printing out K, which is changing at each column, and we have the same number in each column here for each row. So that's how we know it's D.